So I'm Harry Robinson. I report to HICA, and one of my jobs is actually to bring in speakers, and it's one of the best parts of my job. James Bach's work has actually affected the industry and has affected my work as a tester for about a decade, because I don't know if James remembers, but we first met at Quality Week back in 1995, and the first thing we did was argue for 2 hours. And it was a magical moment for me. And it showed me kind of what it really meant to be a tester. And to be a tester doesn't mean you actually have to agree with everybody. So one of the things James is currently advocating for testers, because there is so little that's actually available that's currently state of the art, is how testers should actually go about making themselves experts in their field. And so with that, James.
Thank you, Harry. This is a very bold and arrogant titled talk, Becoming a Software Testing Expert, because after all, who could possibly give this talk except someone who seems to consider himself a software testing expert? Well, I do consider myself a software testing expert, and partly for reasons that you probably don't know about yet, because you may or may not, but probably not. You probably don't go to all the testing conferences and talk and argue with people who write testing textbooks, so you don't know the secrets of how do you get to be a software testing expert? How do you get to be considered a software testing expert? I'm going to spill them all for you here. I'm going to tell you how it really goes down, how it works. First thing you need to know is there's absolutely no authority in the world that says who a software testing expert is. Phew. Okay, don't worry about that. There's no authority. You know, when I published my book, Lessons Learned in Software Testing, nobody checked to see if I was, or any of my co-authors, whether we knew what we were doing. They just published it. So now I'm a published author in software testing. And it was remarkably easy. And it makes sense now to me as I look at most software testing textbooks on the market, and I see that they are, in my opinion, completely worthless or almost completely worthless. I go, oh, now I understand why. Anybody can write one of these things, and then they can go to a conference and say, I'm a testing expert. So look, I'm a special kind of testing expert. I'm the kind, the kind that invites you to be skeptical about my status as a software testing expert. Be skeptical. Now, if you Google me, you'll find lots of hits associated with my name in software testing. Okay, but that doesn't necessarily mean a lot. There's a bunch of other people who also get a lot of hits. But at least Google seems to think that the Google magical supermind system, the all-knowing global supermind, it attaches me to software testing on a regular basis, so that's kind of cool. And maybe increasingly, as we go into the future, Google will be the arbiter of these things. That's my prediction. Everyone will just get Googled. That's like, you know, you're up for Supreme Court justice? Well, let's Google you first here. That'll be more important than the ABA designation of your qualifications. I want to invite you to take a challenge, an expert tester challenge. I'm going to put up a few problems here. I'm not going to give you the answers to these problems. I'm happy to talk with you offline about the answers to these problems. But I want you to know the kinds of problems that I am expected by my clients to answer for them lickety-split, off the top of my head. Okay? I've got to sound smart while doing it. I've got to sound educated. I've got to be aware of what my competitors are thinking in these arenas. Okay? Take any of these claims. Let's say it's important that testing be repeatable. Analyze that. Now what happens? What happens in your mind? What happens in your heart when someone says, analyze? It's important that testing be repeatable. Do you have anxiety? Do you wonder, well, what kind of analysis? I mean, it's so vague. What happens in me is excitement. I have so much to say about this. I can talk about what they say at the conferences. I can talk about what they say in the books. I've got lots and lots of stuff to say about it. And I can write a whole report on any one of these, just analyzing it from different points of view, various kinds of analysis. Okay? I suggest to you that if you want to have a public reputation or reputation in any community as a fabulous tester, among other things, knowing how to talk about statements like these, how to look at the pros and cons, how to question the meaning of each word in the statement, and relate that back to testing methodology. And not only your testing methodology, but the testing methodologies of the world throughout history. That ability to do that and to smile while you're doing it is a big part of what it means to be a testing expert. Now, I'm going to share with you what I think of as the non-obvious secrets of becoming a testing expert, okay? Not the obvious ones. I mean, obviously, you should do testing. Have experience as a tester, that helps. Read some testing books once in a while, that helps. It helps even if they're worthless, because they are worth something. Even the worthless testing textbooks have one value, and that is you can say you know what that author says about testing, and that is if you're a testing expert, as opposed to someone who just does testing really well, you've got to be able to comment on what the other thinkers are saying about testing. So, I mean, they're the obvious things that if you just sit for 2 minutes and think, how do you be a testing expert? Well, obviously, you get a degree in software testing, and then you get your master's in software testing and your PhD in software testing, which, by the way, none of those things exist. And you read a lot of research papers, and then you have to write articles, and you have to speak at conferences, and you have to do lots of testing over a period of many years. Okay. Those are all the kind of the obvious things. I'm not going to dwell on those very much, except I want to point out that some of that is wrong. Actually, it may take less experience than you think to become a testing expert. It may take less reading than you think, and it may take different reading than you think. But you do have to struggle with stuff like this. How about this? Here's a simple problem. You're using a calculator. You press these keys. What is the expected result? Can you answer this? I'm not going to tell you what the answer is. In fact, if you're looking at this in the Google space of Google Video, stop the video. Try to answer this before you see my next couple of slides. Quick, stop it. No, too late. How about this? 2 events overlap. What are the test cases? I need to test the risk that if these 2 potentially overlapping events do or do not overlap, that there will be some kind of terrible thing that happens. How do I analyze the combinatorics of that? How do I frame the problem? What do you do when somebody throws a problem like this at you if you're a testing expert? Okay? These are the kinds of things I've got to be able to do and look smart doing it. How about this? These are real common. Quick, what is boundary testing and how is it done? It's one of the most basic test techniques, boundary testing. And yet, I was at a conference recently where we tried to do a task analysis on boundary testing, to rethink boundary testing. And what we found when we applied task analysis methodology from education theory to boundary testing is we found out there's a lot to boundary testing that none of us present had ever quite put into words. And I realized that I had an entire day of material for teaching boundary testing that I didn't even know I had until I really thought about this and analyzed the task of boundary testing consciously, on purpose. In most testing textbooks, you see boundary testing horribly trivialized and oversimplified. I promise you, it's a rich and interesting idea to do boundary testing. I'll just give you one hint. How do you know what a boundary is? How do you test boundaries that are invisible? Boundary testing, if you're going to be super fantastic at it, you have to be able to test invisible boundaries that no one identifies, that nobody knows about, that emerge from the interactions of complex systems. Gee, how do you do that? Fascinating problem. And what do you find in the textbooks? Here's what you find in the textbooks. Step 1, ask the developer what the boundaries are. The step 2 that they don't tell you about is step 2, believe whatever you're told. It's implied. And what I do, because I'm a professional tester in my own idiom, is, did my system just go down here? No, it's back up again. All right. You never know what's going to go wrong. I'm a tester. I'm ready for anything. I'm like Inspector Clouseau in those Pink Panther movies. I instruct all my colleagues to attack me randomly. Speaking of that, I encourage any of you to ask a question or make a comment at any time. I'll repeat it into the microphone here, or if you're close enough, then you will, I'll give you the microphone, okay? And you can challenge anything that I'm saying. That's how I become an excellent tester in my own way of thinking about it, is I associate myself with the most challenging minds. I make rash statements, and then I sit next to Simon Field, and he says, well, you have to think about it in a number of ways, and I get smarter. Simon Field's here today in the audience. He works at Google now. I worked with him at Borland International in 1992, 1993, 1994. I recognize now that a lot of what I do as a tester came from arguing with this guy day in and day out about epistemology. I don't think I knew what epistemology was until I met Simon Field. And so that's how I hone my mind. That's one of the things that I'm going to recommend to you too, is you find people to criticize you. So I'm going to invite you to do that. Now, traditional boundary testing says you find out what the boundaries are, you hear a rumor about the boundary, you believe it, and then you try one before the boundary, one after the boundary. What I do is I ask what the boundaries are, and then I don't believe a single word I'm told, because those programmers have no idea where the boundaries are. A little about myself. I started as a programmer. After I quit high school, I became an arcade game programmer for Spinnaker Software. Based on that experience, I was hired to be a test manager at Apple Computer, not having had any experience as a tester or a manager. I was at Apple Computer for 4 years. A few months after I joined there, I became the test methodologist for my group at Apple Computer. That shows how screwed up our industry is. And then I went to Borland and got lots of wonderful experience there with bright people doing agile development. It wasn't called agile development back then, but that's what we were doing. Small a agile. And now I travel the world training the minds of testers. That's what I like to do. I challenge testers with problems, and I try to get their neurons to respond. And by doing that, their neurons get all muscular. That's the idea. But I started as a programmer, and that's one of the reasons why I know that programmers have no clue what the boundaries are. You ask a programmer what a boundary is, and you get, well, this is what I think the boundary might be. Go away. I'm busy. And so as a tester, what I have to do is take these little clues about what the boundaries might be, systematically not believe them, but systematically use them to try to do boundary testing while looking for the invisible boundaries that no one ever anticipated. You might think this is impossible to do. And if this were any place other than Google, I might let you go along and say, well, maybe it's impossible for you to do. But the kind of thinking that they encourage here at Google is exactly the kind of thinking that I'm trying to promote for the entire industry. The kind of people who can test for the invisible, to test for what's not there. And there are ways of doing that, and I can show them to you. Can you explain your test methodology cogently in 5 minutes or less? I can. I can because I've practiced doing this. And this is, again, is something a testing expert needs to do. You know, my first question is, where's the whiteboard? Show me the whiteboard. I'll give you my test methodology right there. You don't have a whiteboard? You got a napkin or something? Can I write on this table with this crayon here? I can draw it in the air if I must, but you know, diagrams help. Absolutely, I can explain my test methodology. I can explain it in a way that engages you in a conversation about it. This is what a testing expert needs to do. Now, I believe for any testing problem, for any claim, like the first set of claims I showed you, that a non-expert is more likely to look for book answers, to look for pat answers, to say, yes, this is right, that is wrong. Or if they don't know, they'll say, I don't know, and they'll stop. They'll freeze. I don't know. Like C-3PO, you know, with smoke coming out. What I'm looking for in a budding text expert is this kind of behavior. Questioning the basis of the question. Being aware that what I've just been told is a projection from a hyperdimensional space onto a lesser dimensional space. And information has been lost when it's been turned into an English sentence. And I must find a way to replace that information, to bring that information out. Every test problem in the world is a murky problem. Remember that problem with overlapping events? One question that occurs to me when I address a problem like that is, can an event end or begin simultaneously with another event? In some contexts, the answer is yes. In other contexts, the answer is no. It's digital space, it's discrete events. You can never have exact simultaneity. But in other cases, yes, you can have exact simultaneity. And that changes how I develop test cases for this, among many, many other things. So I'm looking for, what are the possible answers? What's one way to solve it? If you don't know, tell me how you go find out. Tell me what kind of analysis that you do. That's what we're called upon to do as experts. Because the expert, the testing expert, that's the last line of defense. There's no one past that. If you're considered an expert in your community, you're considered to be the person who can figure it out. Here are my credentials. This is my 8th grade diploma. This is my high school transcript. Physics, by the way, is my favorite subject. I got a 49 in physics. Never got a 49 in any other subject before. Why did I get a 49? Because I felt that the physics labs were an insult, not only to my intelligence, but to the meanest intelligence of every person in that school. And I wasn't going to be part of a system that trivialized physics, a subject I hold so dear. So I stated that to the physics guy, and he gave me a 49. I took a couple math classes in 9th grade. I never got a grade for that because I didn't take the final exam because I had to go to the University of Vermont to take a calculus course that was starting on the same day as the final exam. And my teacher was very upset that I didn't take his final exams. He surprised me the next year and forced me to take these exams that I had no idea that I was supposed to study for. So I eventually did get a grade the next year. This is my credentials. I have no certifications other than, of course, a level 1 paraglider certification, a PADI open water diver certification, a driver's license in the state of Virginia anyway. My state of California certification has lapsed, as has my motorcycle license. And I've got my student private license, pilot license, but it's lapsed. I have to go and get that again. These are the only certifications I know of, other than the time that I was detained by Canadian Customs while they scanned my computer and certified that I was free of hate literature and child pornography, which they granted me that certification. But I have a feeling that that expires every visit. But I do have this. March 16th, 2006, page 371 of the transcript. PADCOM versus NetMotion Wireless. A Delaware court, the Honorable Sue Robinson presiding, declared that I was an expert in software testing. And not only that, but they threw in networking and computer programming too. So that's what I'm holding on to. Declared to be an expert in a court of law. And what did the court have to know in order to declare me an expert? My resume was more or less read into the record, and they just said, whatever. And it's interesting that the other side didn't object. I think that was some sort of agreement where they weren't going to object to me if we didn't object to the professor from Rice University that they brought up to try to attack my work. But my side prevailed. The jury went with good old Bach here. So screw you, Rice. All right. This isn't going out on the air, is it? Here's what I'm talking about when I talk about a testing expert. Someone who's very good at testing, someone who is considered to be an expert in testing. That's the second definition. That's a community designation of expert. The first one is an internal thing. Are you actually really good at this stuff? Becoming a testing expert means becoming someone who is recognized to be an excellent tester. Becoming someone who really feels like an excellent tester and who has the self-criticism, have that mean something. For all I know, you're all expert testers. I don't know. Maybe you are. The difference, I think, is I have a public reputation. I want to share with you how to get your own public reputation as a tester so that you could turn that into money because, by the way, public reputation equals big bucks. Reputation equals money. So it became a big issue in this court case. They brought out how much money I was making to do that thing, and it was like, oh my God, they pay a tester that much? It's all because of reputation. So it's kind of cool to work on this stuff if you really like testing and you want to be in this career. Now, here's one idea of perfect testing, okay? The infinite process of comparing the invisible to the ambiguous so as to avoid the unthinkable happening to the anonymous. Does that sound like a challenge to you? It is a major, major challenge. I didn't just make these words up. It is an infinite process, if you want to do it perfectly, to test the entire space. And it's easy to make a little inductive argument which demonstrates the infinity of testing. All you have to do is imagine any test at all. Just take any test. And now, at a time delay of, let's say, 1 millisecond at some point in the test. That now is a different test. And you go, no, it's not a different test. There's no way you can tell me there's not a different test. What you're saying is you hope it's not a different test. You hope that 1 millisecond time delay doesn't make a difference, but there's no way you can prove it doesn't make a difference. And the history of software is full of examples where little milliseconds did make a difference. So it's a different test. It's just not one that's different in a way you happen to care about. Now I can make an infinity of those, can't I? An infinity of combinations of time delays at different places inserted into tests. We can easily see that there are many, 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 many tests. And what we're trying to do is we're trying to decide what kinds of tests we can safely ignore. And that is a fascinating problem in modeling, in mathematics, in heuristics, in the rhetorics of software testing. We're comparing the invisible to the ambiguous. The invisible is software. Software is invisible. I use Google. I have no idea which Google server gave me the answer that I get. And if I try that same query again, am I going to be trying on the same server? Probably not. I don't know how it works, but I imagine there's some sort of load balancing algorithm. It's invisible. I don't know what's going on. What I see when I'm running software is I'm seeing an illusion of software. I'm seeing some little slice of this vast hyperdimensional thing projected onto my screen in 2 dimensions, in 3 or 4 dimensions, depending on whether I'm doing sound and whether there's changes over time. It's invisible, and part of what I do as a tester is I get little strobe flashes of what this software could be, little strobe flashes, and I try to draw inferences from that. It's ambiguous. I'm comparing this to something ambiguous because different people want different things from software, so I can never be quite sure. Is this good or is it not good? Or you could go, well, look at the requirements. But the requirements themselves are just some kind of political détente, some kind of no man's land, where a group of people have come together and decided to stop arguing at a certain moment and say, well, I guess this is good enough. Each of them having a different interpretation of it. And here comes the tester, the innocent little tester, like a little bunny rabbit into the no man's land. And then the software does something and they go, oh, look, it does this and that doesn't really match with that. Could that be and then they get blown up by all these angry people saying, no, that's wrong, or yes, that's right. We are in the center of the maelstrom of all these disagreements that our clients have as to what the software really should do. But we have to make it clear what the software actually does do. We're avoiding the unthinkable. I discovered this when I worked at Apple, and no one wanted to talk about risk. I even had one leader say to me, risk? James, we don't want to talk about risk. We're entrepreneurs. We take risks. Okay, but don't you want to know what risks you're taking? Shouldn't we talk about that? No. I find that frightening myself. But it's really hard to get people to talk about what if something goes terribly wrong? If you go to a typical user and say, what are the 10 things that will make you faint with terror if they were to happen on your computer right now? And they don't want to talk about how they're losing all their email records for the last 10 years or anything like that. That's negative. To speak the name of the evil is to invoke it. So I have to test for that stuff with people who don't want to talk about it. They don't want me to tell them about my day as I tried to save them from the evil. And I'm trying to prevent this evil from happening to the anonymous, because I don't know who's going to use this software in the future. I don't know who's out there. I have to make guesses about who's out there. This is a challenge. And to me, it's a delicious challenge. I love this kind of thing. I love unsolvable philosophical problems. But one of the things I do is I work from a different definition. I look at that first definition of testing and I say, that's an interesting challenge. Now, here's how I actually think about testing, doing it from day to day. Testing is questioning a product in order to evaluate it. And this focuses on the cognitive process of software testing. Testing is a process done by human minds, highly skilled human minds if it's done very well. And we need to know how to question things. It's an open-ended investigational process. Some people talk about testing as if it was a process much like doing inventory in a grocery store. There's 3 cans of peas up there. Let's check and see how many cans of peas there were supposed to be. Why there were supposed to be 3. Test passed. That's clerical work. That's unskilled labor. And if we think that way about testing, let's not be surprised when our jobs disappear to whatever the cheapest conceivable geography there is on the planet. You know, today it might be India or Pakistan or China. Tomorrow it's going to be the Yanomami tribesmen of the central Amazon are going to get all the testing work, you know. There's they've discovered a little community of people somewhere, I think it was in South America, who don't even have numbers yet. They don't actually count. Those are the people that are getting all the testing business. If we keep letting people think that testing is unskilled, simple, just check this against that kind of thing. It is not that. Fantastic testing where you find the bugs, the bugs, the non-obvious bugs, the dangerous bugs, the ones that are going to be on CNN. If you don't find them, and not CNN.com, but the actual, the satellite feed, those are the ones we've got to catch, and they're not easy to catch, these things, because everyone else, all the non-expert testers are going to look at it, and they're going to pronounce it blessed. Now, put yourself in that situation. You come in through the swinging doors like in the saloon, and you look around, and you want to have better perception about where the bugs might be. You want to smell danger where other people just smell lilacs, okay? You want to smell the danger that's under the lilac smell. That smells like a fragrance, an artificial fragrance. There's something going on here. I'm developing myself into that kind of person. That's the focus of my whole career. I want to help you do that too. This is what we're about. Now, what's special about testing, aside from that, is that no one's going to teach you how to do it. Probably no one's going to teach you how to do it. There's a few people like me going around trying to teach testing skills, but there are not very many, and your company generally doesn't send you to this sort of thing. So you're kind of on your own. And it's very easy to do testing and think you know what you're doing, and you really don't, unless you apply vigorous self-criticism to what you do, and you get involved with a community of people vigorously criticizing itself. But learning testing on your own doesn't cost so much. So at least there's some kind of hope. I've heard that a lot of you are into computer science. You have computer science degrees. Well, testing ain't part of computer science. Computer science likes to think that testing is part of computer science. But if you look at a computer science journal and you look at articles about testing in there, it's like somebody treating cacti as the whole of vegetative life on the planet by looking at a desert and seeing a little cactus sticking up. What you generally see in computer science journals that talk about testing is ways of optimizing sets of test inputs using various algorithms, assuming that these laboratory conditions prevail for all possible situations. Further research is needed. And it helps a little bit, but it doesn't even scratch the surface. It doesn't even begin to deal with the actual testing problem. The actual testing problem is a jungle crossed with a marsh, crossed with some kind of weird Cthulhu, H.P. Lovecraft environment where you could get swallowed up at any moment. It's like Hoth, okay? It's crazy. I go into a testing problem and I have no idea what the boundaries of that testing problem are. I have to discover what they are. I've got to set a perimeter. I've got to identify my assumptions. None of this has anything to do with computer science. It has very little to do with algorithms. Now, I think knowing about computer science can help you be a fantastic tester. And I encourage you to know about computer science, but don't confuse testing with computer science. Testing is actually a social science. It deserves to be thought of as a social science. Now, I'm from a certain community. I identify the community I'm from so that you don't think I'm speaking for everybody. Lots of people think I'm full of it, okay? You should know that. Make up your own mind. But I'm part of what's called the context-driven software testing community. We adhere to these principles. Among them, there can be no such thing as a best practice. Best practice is a marketing term invented by marketing people or by consultants trying to impress and overwhelm and intimidate people who don't know what's going on. What you actually have is no best practices. What you actually have are practices that are more or less effective or more or less interesting, depending on the context. And what we need to do as testers is we need to read the context. We need to understand the problem before we talk about solutions for the problem. Just like a doctor needs to maybe examine a patient before deciding that the patient needs chemotherapy. So the context-driven community, we're a ragtag band. We're a bunch of rebels. We're trying to think about testing in terms of dynamics, problems and solution patterns, heuristics. We're trying to see it as a social science, and we use the ideas of social science to further our education. And I want to share with you some of that. But first, let me say something a little generic about experts. I think experts have these things and experts do those things. We have situational awareness. That's a term I learned while learning to fly an airplane. Situational awareness means I'm maybe focused on this, but I know what's going on around me. I give people testing problems that are designed to help them fail if they don't have situational awareness. If they don't ask questions like, hey, what kind of equipment do I have to solve this problem with? They don't ask that question, they never find out. There's a room full of equipment right next to them they could use to help solve the problem. Instead, they just assume that, oh, I can only solve it with my bare hands and my naked eye. That's all I have to solve this testing problem. Poor little me. And I try to evaluate when I'm interviewing testers, when I'm training testers, their situational awareness by looking at the kinds of questions they ask me to probe the situation around them. What kind of project situation are we in? How much time do we have? Who's involved? Who's on the test team? What kind of deliverable does it have to be? Who's our customer? What information do I have on my desk right now about this problem? What information is available via the various electronic mechanisms? Situational awareness is where you know how to ask those questions. And most testers I train have pretty bad situational awareness. Work on that. Confidence in confusion. A lot of us are frightened of confusion. If we're confused, we don't want anyone to know about it. But you know, my older brother Robert, not my younger brother, the other tester guy who got his Google video before me, okay? The one who stole my thunder with his talk on exploratory testing. Okay, my older brother's an airline pilot. He knows that if he's confused about what's on the airplane dials, what do you call those? If he can't think of the name for the avionics, he knows that's important information. You cannot fly an airliner and be confused about the state that the airliner is in. You know that's important. You don't try to hide it. I hope no one notices that I forgot what this lever does, right? So an expert has confusion, confidence. If I'm confused, I'm confident that that means something important. I can work with that. That's a tool. Someone who's not an expert is more likely to think of confusion as a little terrible demon that they must try to repress. You need a colleague network. You need trained reflexes. You need an awareness of your limitations. There's certain kinds of testing I'm really good at, and other kinds of testing I haven't developed the skills to do yet. And I don't mind because my clients don't ask me to do that kind of testing. But as soon as they do, I need to find one of the people in my colleague network who's good at that kind of testing, call them up, get them to quickly transfer that skill to me through some sort of a neural download, and then I can do that work for my client. I need diverse experiences. I need relevant knowledge. I need mental models for problem solving, what educational researchers call schemata. Problem solving schemata. And I need schema activation heuristics. Huh? I'm throwing around the terminology from education theory. Doesn't it make me sound like I know what I'm doing? Huh? Now, of course, if you're good testers, you know to question that. Maybe I'm just throwing around these terms and I don't really know what they mean, and maybe I'll crumble as soon as you question me about exactly what is this stuff. Okay? I'm just giving you fair warning about that, trying to tutor you in how to deal with someone presenting himself as an expert who might not be an expert. Now, I'm not an expert in education theory, but I have a friend who just got her PhD in education theory, and that's part of what gives me the confidence to talk about some of this stuff as I've worked with her to learn about some of this stuff. Developing these mental models for problem solving, that's tough. It takes a while. I have a model that I use. I guess I'm going to show it to you in a few minutes. If I had a whiteboard here, I would draw. You know what? I'm going to use virtual whiteboard technique. Okay, here's what I'm going to do. All right, I'm going to write it up here on this whiteboard here that is hanging invisibly between us. Okay, this is a mnemonic that I use for analyzing any testing situation. Okay, it's part of my mental model for problem solving and testing. And it's a mnemonic that helps me remember this heuristic model. Okay, I'm just going to read you off the letters that belong to the mnemonic. CIDTESTD SFDPOT CRUSSPIC STMPL FDSFSCURA. 36 letters that spell testing to me. Pick a letter. You see it up there. Pick a letter.
C.
C. Okay. Which C?
Third one.
The third one. Okay, let's see. CIDT. Okay, that stood for compatibility. Good. It reminds me to think of compatibility testing as part of what I have to do. The compatibility of this system with other systems like it, with platforms. And by the way, there's a P there in the SFDPO. P stands for platforms. It reminds me to analyze platform dependencies. The first C, I thought you were talking about the first C at first, that stands for customer. It reminds me to enumerate the customers. Who am I working with here? Every one of these letters expands into a word or phrase, which reminds me of a dimension of analysis. Even under pressure, considerable pressure, I can analyze a situation. I practice with this stuff. Now, when I was a younger testing expert, I thought, here's what I need to do. I need to come up with this stuff, and then I need to tell you all about it so you can use the same thing I do. But now that I've done a little more research into education theory, I've realized something, and that is, that's not very effective. The more effective approach would be if you came up with your own model of software testing. It'll be much easier to remember it. It'll be very easy to change it whenever you feel like it's let you down in some way, just like I do with mine. I certainly can share with you my model, and I do. It's right up on my website. But I want to give you permission right now not to use it. I want you to give you permission to take it and change it any way you want, to reword it, to make up your own and ignore mine. The process of becoming an expert is not necessarily the process of learning to copy every other expert that's out there. But you ought to be aware of what's out there so that you can make some choices about it. Okay, and experts have this, experts do this sort of thing. Self-criticism, self-training, coherent explanations. You've got to be able to justify your methodology. That's why I have these models in my mind that I can speak about like that. Because if someone says, why should I believe your test methodology is any good? I go, let's talk about it. Let me lay it out for you here. And it starts looking like that whiteboard over there, like any number of whiteboards here at Google, just full of stuff. Which part of it would you like to talk about? And if I can expand on that on demand, people go, whoa, this guy knows what he's doing. I have not yet found someone who has the patience to sit through an entire description of my test methodology. They all give up. They'll tap out. They go, okay, you know testing. You know testing. Please stop talking to me about this. I'm so bored. Okay. And I find that rhetorically useful. Steve McQueen, Towering Inferno. This is where I get my mental image of an expert performing, okay? I found this on Google last night. This is what he says when he comes on his first scene. He's trying to size up the fire situation in Towering Inferno in the 70s. He says, exhaust system, sprinklers. Why aren't the sprinklers working? And then he turns to the architect. Jim, give us a quick refresher on your standpipe system so you can learn on the fly. Are these elevators programmed for emergencies? What floor are your plans on? Okay, he's trying to figure out where he should set up his forward post. He figures it out. He says what he's worried about. He gives a preliminary analysis. Then he wants a list of tenants. The guy doesn't understand why he wants. He starts explaining, this is why I need it, because of these toxic gases. Should I go on? And the guy goes, no. One tenant list coming up. I loved this. It was years. It was 1999 before I realized that in 1978 or something, I got a picture of what it means to be an expert, and I wanted to emulate that. Steve McQueen, the fire chief in Towering Inferno, is the expert I want to be. Not in the realm of fires, but in the realm of sizing up a testing situation. And I want to share that because it's a lot of fun to feel like you could come in and people are all confused around you. And you could say, okay, people, I know what questions to ask. I know what to do. Calm down. I'm an expert. I love that idea. Okay, now expertise is situated socially, psychologically, and technically. Here's my personal vision of testing expertise. I say to people, I can test anything. Yes, under any conditions, in any time frame. Can you do that? I can. That's my personal vision. And then I go into a little bit into the fine print. Okay, I can test anything relative to my standing in the local community, because different communities define expertise differently. A government community is very different from a video gaming community when it comes to testing, for instance. And it depends how hard I want it. And it depends on my technological insight. The more I know about the technology, the better I will be able to test it. All other things being equal. There are some downsides to knowing technology, but pretty much knowing technology makes you better as a tester. And there's a little bit more I have to say. Relative to these things, I can test anything such that, and the top one is, or the second one is the one I think is most important. I do at least as well as any other expert would do in the same situation. Okay, if I'm with another test expert and we're competing, and that guy knows just as much about the technology as I do and wants it just as much as I do, and then I'm saying that an achievable vision of test expertise is I can test it about as well as he can. And these other things, I'll deliver useful results. I'll collaborate effectively with other people. I'll advise my clients about how they can help me do better work. I will faithfully and ethically serve. I have a code of ethics. I use the IEEE code of ethics. I also like the ACM code of ethics, and that guides me sometimes in what I'm doing. It helps me justify not doing certain things that I believe are unethical. And because I'm independent, it's easy for me. I just fire my clients if they want me to do something I think is not right. Here's my personal testing syllabus. Now the rubber's meeting the road. You want to know what it takes to be a testing expert? This is my vision of what you have to know to be a great, fabulous testing expert. And notice how different this looks than what you expected. I think you need to know about general systems theory, general systems analysis. I think you need to know about epistemology, applied epistemology, which includes things like experiment design, the logic of experiments, the ability to analyze text that people put together where they describe what they want, and the ability to break that down and to get hidden meanings out of it. Information theory is important too. That should be up there. I just realized it's missing. Cognitive science. How do people actually think? Thank you. How do people actually think? Not how should they think, that's epistemology, but how do they actually think? What kinds of biases afflict people? Did you know that there's a phenomenon called inattentional blindness? Inattentional blindness is about how you are unable to see certain things. When your attention is occupied over here, you're unable to see things that are happening right there, even if they're pretty outrageous. Even if something walks across your field of view and you're not focusing on it, and your attention is taken up with some cognitive activity, you will not remember seeing that guy in a gorilla suit going by. It's called inattentional blindness. Part of becoming a testing expert, I think, is becoming aware of things like inattentional blindness, because when you're looking at screens and you're trying to say, is the test passing or failing? You know, I was trying to break into somebody's system the other day. The first time I was ever paid to do penetration testing. It was wonderful. I love penetration testing. I hope I'm paid to do it again. But I broke into the system a half hour before I realized I'd broken into it. I was doing a search and I was getting hits that I wasn't supposed to get. And I just thought it was the same thing. I just said, nothing's happening, nothing interesting. And I didn't notice that the number of hits had changed from 67 to 119 because I wasn't looking closely enough and focusing on that aspect to see that not only had that number changed, but all the results had changed. And I just didn't notice. I go, it came back with results just like it did last time. And after a half hour, I realized, oh my God, I can see all this secret stuff. Cool, I broke in. I used URL editing to break into that particular system in that particular way. And I just thought that was fascinating. That I thought I was looking at the screen, but I really wasn't. I was only looking at certain aspects of the screen, and my brain had gone numb. It had gone to sleep in a certain way. It's inattentional blindness, or something like it. But I study this kind of thing because it gives me humility about what I can and cannot see, about what I should expect of myself as a tester. That's what cognitive science gives me. It also gives me ideas about how to use heuristics, which are fallible methods of solving problems, as the basis of a test methodology. My test methodology is entirely heuristic. I do not use algorithms in my testing except as heuristics. In other words, there's no sure way to test anything. You're on your own there. You've got to use heuristics. You've got to know how to use heuristics, just the way you have to know how to be with a dog, a dangerous dog. You've got to keep it on a leash. You don't let it run around killing people, cornering people, and you don't want to let your heuristics go crazy too. A lot of process improvement falls apart because process people take a perfectly good heuristic, like a little friendly dog, and they let it off its leash. And now everyone has to follow this rule as if it's a hard and fast rule instead of a heuristic. And now it's attacking people. Now we work for the heuristic. It's a terrible problem in process improvement. Well, anyway, cognitive science is part of learning how to deal with heuristics properly. Mathematics, those are the areas of mathematics I find useful to study. Testing folklore, that's an important part of testing too, but I'm aware that all that stuff in the testing textbooks, most of it is just folklore, unproven stories. It's hearsay about how to test. But it helps me with terminology. I also need to learn rhetoric. I also need to know about technology, of course. I need to know about software process dynamics, software engineering economics. Personally, this is the stuff I learn about. Notice that on my reading list, there's no testing textbooks. These are books that change the way I think about testing, and not one of them is a testing textbook. You memorized that yet? Good. Now, how much do you have to learn about these things? You have to overcome intimidation. That's one thing I want to leave you with here. It's very important. Overcome intimidation. For every one of the subjects I just put up, there was a time when I was intimidated by it, and I've overcome that. I know enough now that someone who knows a lot about it can't back me into a corner. Yeah, sure, you might know more about it than I do, but I know something about it too, enough not to be bamboozled and faked out. Now, I want to get to the point where I overcome incoherence. That means I can tell a coherent story about that subject matter and how it relates to testing. And many of those subjects, I feel I've reached that point, not all of them, maybe half of them. And then I want to overcome competence. Overcoming competence means overcoming the complacency that comes with being able to do a good enough job and then starting to take some risks, experimenting, innovating in those areas. I feel that in testing as a whole, I've overcome my own competence. I pushed past it. And now I'm experimenting, and now I'm not afraid to screw up because I know I'm smart. I know I'm good at this stuff. So I can screw up, and it doesn't reflect badly on me as an expert. But for any one of the constituent subjects, I may not have reached this point. I would say for most of those constituent subjects, I'm here or here. But overall, when you take them together and talk about applying them to testing, I feel like I'm at level 3. So that's how I think about it. This is how I develop my expertise. There's 3 big things that I do: study and model, experiment and perform, observe and record. They reinforce each other. Study and model is that's where I'm just thinking like a philosopher. What's going on here? What's going on here? This is where something's happening and I'm taking data down about it during my projects. I'm usually one writing more notes than anyone else about when was that decision made and why did we do this technique instead of that technique. And then I try experiments and I try out the skills and I work with other testers. Okay? This is the test model I alluded to earlier. I have this in my head. Bang! I've got lots of other models, but this is my main one. What about certification? I recommend that you avoid weak certifications. And every certification I know of so far is just a weak certification. Any tester certifications you may hear about at this point in time, every one of them is a scam for consultants to make money off of your fear. That's what it's about. Your fear that you won't be able to get a job as a tester, so you got to get the CSTE or the ISEB or the ISTQB, and not one of them has a shred of foundation to it other than a group of people got together and saw a business opportunity. I've been asked to be a part of some of these, and I've turned them down. I've been asked to be a part of some of these, and I've said yes. In '95, I was part of the CSQE process, and that's why I know whereof I speak. I repudiate the Certified Software Quality Engineer certification, and I was on the committee that created it. So I know something about how it happened. I think these weak certifications cheapen the craft. I urge you to ignore them. Here's what I think you should do. This is my advice to new experts. And I think among all of them, building and protecting your reputation as a tester is the single most important thing you can do. I can't emphasize it enough. Reputation equals money. I've made hundreds of thousands of dollars that I couldn't have made if Google didn't show so many hits for my name in a favorable light with regard to testing. If I didn't have people like Kem Kainer certifying me saying, he's a good guy, you should go get his class. And so that's really made an impression on me when I trace where my business comes from. That reputation has a lot to do with it. And the big difference between being an experienced tester and being an expert tester is your reputation. Who knows you? Michael Hunter from Microsoft. He's got a lot of hits. He writes a blog. That's the thing. He hasn't written any books. He just writes a blog, but it's a widely read blog on software testing. Jonathan Cole has a wonderful reputation. He also doesn't have a book yet. He doesn't even have a class, but he writes a blog and he's a good writer. He writes this blog called Collaborative Software Testing. That's how I got to know him. Okay? So these days, blogging is a big part of gaining your reputation as a tester. All right. Anyone have any questions? Nobody interrupted me. I guess I was talking too fast, but anyone have any questions? Anyone want to challenge anything I'm talking about here? I've got a couple minutes left, don't I? Is anyone here? Yes. Which would be the best book to read about domain testing? Okay, I would say that there's no really good book on domain testing, but there's a fantastic paper by Kem Kainer on domain testing. And there also is a seminal paper on domain testing by Balser and Ostrand. Okay, so read the Balser and Ostrand paper, which, by the way, I can get for you. And also read Kem Kainer's paper analyzing the state of the practice of domain testing, where he talks about 5 different meanings for the term domain testing, and then talks about his preferred meaning for that and why he thinks that is a better way to think about domain testing. As I think those are the 2 best things. If you are really interested in a book, then I would say Paul Jorgensen's book, Software Testing: A Craftsman's Approach, has a pretty lucid discussion of domain testing in it as well. And that's what I think. Oh, you're asking for my email? Oh, my email is james@satisfice.com, which is on my first slide here. This is my business. This is the way I market. So I'm happy to get emails. And actually, what I do is I never charge for email consulting. I'm just flaky about it. But it's free, so lump it. Okay? So I don't charge, here's what I love to do. I love when people give me testing problems. It's like, you'd think that doctors would love to get medical problems. People just throw out of medical problems and ask for free medical advice, but you keep hearing doctors go, oh, I don't like that. I love getting testing problems. Bring me your huddled masses of testing problems. I'm writing a book on testing problems right now, and I'm trying to collect as many as I can. So you want help solving a testing problem? Lay it on me. I'll give it a higher priority than I otherwise would. But I'm always happy to get any emails from anybody, and I answer them as I have the availability to do that. Okay, anyone else have any questions? See, I've managed to intimidate you all. You're afraid to question my expertise. It worked again. Yes.
Can you get these slides?
My slides? You can get them from me. I can put these up on my my website, but I need you to email me to remind me to do that. If you send me an email, I will say, oh yes, and then I will quickly upload them to my website and give you a link. All right, they'll be on some link. They'll probably be on a bste.pdf off my website. Will probably be what I'll name it, and it's also on Google Video. So there's always that. All right, am I out of time, Harry? What's the deal?
Yeah, out of time.
All right, thanks for coming and listening to me harangue you. I enjoyed myself.